Alright, so today we're talking about the product rule and the quotient rule, how to get those formulas, and then how to utilize them. So, the first thing we're going to talk about is the product rule. And here's our problem. We need to find the derivative with respect to x of x times sine x. So what does this equal? Well, I can tell you one thing that it doesn't equal. It does not equal 1 times cosine x. In other words, taking the derivative of x and multiplying it by the derivative of cosine x. So the way that we're going to think about this is that we've got two functions, first one and second one, f and g. And as always, we're going to start off with the definition of the derivative in terms of the limit. So the limit is delta x approaches 0 of f of x plus delta x plus g of x plus delta x minus f of x times g of x all over delta x. That is just the basic definition of your derivative. Then, for no apparent reason, we are going to add and subtract first actually, this quantity right here, f of x plus delta x times g of x, and then plus f of x plus delta x times g of x. And the reason is because that's going to turn out to do something really nice for us. So you can see here, everything else is pretty much the same except for what you're looking at in red. And it's totally okay that we did that. We're just adding and subtracting the same thing. The overall value is still the same, but the way that it looks is a little different. So the reason why we're putting those particular terms in is because we're going to do a little bit of rearranging here in this next step. So, limit stays the same. What we're going to do is we're going to grab at f of x plus delta x. And if you notice that we can factor that out of both the first term and that second term, leaving what's left is a g of x plus delta x minus g of x. And we're going to put all that over, or just at least that part right there, over the delta x. In the second part, over here, we can see that we can factor out a g of x. And when we factor out a g of x, we're left with f of x plus delta x minus f of x. Once again, all over delta x. And then what we can do here is we can apply the limit to both of those major terms. So let's go ahead and do that. So distributing the limit, we have limit of delta x approaches 0 of f of x plus delta x times the limit as delta x approaches 0 of g of x plus delta x minus g of x all over delta x. That should kind of look sort of familiar. Plus limit as delta x approaches 0 of just g of x, and then times the limit of delta x, or delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Once again, that last item there, again, also should appear very familiar. So, turns out this first item, as delta x approaches 0, just turns out to be f of x. The second term here is the definition of the derivative of g. The third term is just g of x, because there's no delta x in it. And that last term, said looks familiar, hey, that's f prime of x. So, this is the product rule. And it says that the derivative of what we were asking before is the first function times the derivative of the second function plus the second function times the derivative of the first. And we can do a few examples of this. So first off, just going back to that original problem, what is the derivative of x times sine x? Well, it's going to be the first, which is x, times the derivative of the second. The derivative of sine x is cosine x, plus the second, which is sine x, times the derivative of the first, which is 1. And then if we want to, we can just sort of simplify this, x cosine x plus sine x. Then we have another problem that we can do. Derivative with respect to x of 3x squared times sine x, where the way that you're going to look at this is we have a first function, 3x squared, and a second function, sine x. So the first, 3x squared, times the derivative of the second, which is cosine x, plus the second, sine x, times the derivative of the first. Derivative of 3x squared is 6x to the first. And we can clean this up a little bit. 3x squared cosine x plus 6x sine x. And one last problem, just to make sure we totally understand what's going on. If we've got the square root of x times cosine x, we can once again break this down into a first function and simplify that, or rewrite that as x to the 1/2. And the second function there, cosine x. So the first times derivative of second, so first is square root of x times negative sine x, that's the derivative of cosine, plus the second, so cosine x, times derivative of the first, 1/2 x to the negative 1/2. And if we want to, once again, we can rewrite this in a nice form, negative square root of x sine x plus cosine x over 2 root x, if we want to make that nice and pretty. So that's the product rule, and that's how we utilize that. Next up, quotient rule. And we've got another problem, another dilemma, something we don't know how to take the derivative of yet, and that is something simple like x over sine x. We have no idea what that is. We have no rule that deals with that, not yet at least. One thing I can tell you, it is not equal to the derivative of the numerator divided by the derivative of the denominator. That is most certainly not the case. So we're going to abstract this and think of it as the derivative with respect to x of some function divided by another function. And then, yep, you guessed it, better have a lot of paper. Here we go. We are going to use the definition of the derivative. So the limit as delta x approaches 0 of f of x plus delta x over g of x plus delta x minus f of x over g of x, and all of that over delta x. You can see just we're applying the definition of the derivative there. So then we're going to do a little bit of weird things. We've got to get that numerator having a common denominator in the numerator, if that makes sense. So first term stays as is, but then we're going to multiply that by g of x over g of x minus second term stays the same, f of x over g of x. This one we're going to multiply by g of x plus delta x over g of x plus delta x. So that's the whole numerator. And then rather than continually to divide it by delta x, we're going to multiply by the reciprocal of the denominator. And then next up we're going to distribute that delta x all the way across. So here we go. So limit as delta x approaches 0 of g of x, f of x plus delta x, minus f of x times g of x plus delta x, all over that common denominator times the delta x. So you can see the common denominator, g of x and g of x plus delta x, and that delta x we've also pushed down through the denominator now. And then we're going to do, once again, this, it's called an unmotivated step, where some brilliant mathematician figured this out, where we're going to subtract and add the same quantity there in the numerator. And I've got that written down there in red. So we're going to say minus f of x g of x plus f of x g of x. Everything else totally stays the same. So the reason there is just, well, once again, as we're going to rearrange some things, then everything's going to become real nice. Well, as nice as the quotient will get, so that is. So if you look at those first two terms, we've got a g of x. So we're going to write the limit as delta x approaches 0, factor out a g of x. What's left over is f of x plus delta x minus f of x, starting to look familiar, and put that all over the delta x. And you say, hey, what about the g of x and the g of x plus delta x? Where's that going? Well, we're going to throw that all the way down underneath all this stuff here in a minute, so just hold your horses. So, alright, so there's the first part, and if we look over here in the second part, oh, put that bracket in there, we've got an f of x in each of those last two terms. So we're going to factor an f of x out, and what's left over is a g of x minus, we've already got the minus out front. Get that minus right out there. That when we do that, the first or the very last term, which has a minus, is going to stay as is. But this other term, the third term, I guess you could say, the f of x, g of x, that's going to turn that g of x negative. So we've got g of x plus delta x minus the g of x. If you're not sure about the minuses, just look there. Everything is totally legitimate as far as why we factor out in a minus and yada yada yada. Sticking the delta x underneath. And then here we go, giant line underneath all of this, and we're going to also write the limit of g of x times g of x plus delta x. And notice that's not a separate problem. That is the limit applied to the denominator as well. We're putting limit in the numerator, putting limit in the denominator, and that's where those other terms go. So wow, giant, crazy mess. But if you look at each one of these, some beautiful things happen. Here in the blue, as we apply the limit process here to this first term, that g of x, nothing happens. It's just g of x. If we apply that limit to this term right here, what do you know? Hey, that's the derivative of f. If we go over here to this, we distribute this limit, apply it to f of x, goes away completely. Actually, it's just f of x. And as we apply limit to this over here on the right, the g of x terms, oh my gosh, that's the derivative of g. And down here in the denominator, as delta x approaches 0, you'll find out that delta x, that delta x there in the far right, is going to go away 0. So we're going to, so imagine as if you have that limit applied to each one of those terms. I'm not going to rewrite all of that with all those limits again. That just gets crazy. But like I said, with that, now that is a mistake with the slash there. Slash is supposed to go right here. That delta x turned to 0. So we have g of x times f prime of x minus f of x times g prime of x all over g of x squared. This is what is known as the quotient rule. Like I said, this is about as beautiful as it gets with the quotient rule. Just a reminder what f and g are. Well, g is the denominator and f is the numerator. Great. So let's go back to our pesky problem which started all this in the first place, x over sine x. So it's going to be the denominator times derivative of the numerator. Derivative of the numerator happens to be just 1, minus the numerator, which is x, times the derivative of the denominator. Derivative of sine is cosine. All of that over sine of x squared. And we can clean this up a little bit. Sine x minus x cosine x. And if you remember, when you're squaring a trig function, you can put that little square in between the trig function name and the x. So you put a little, so this would be sine squared of x. That's the same as this sine of x quantity squared. All right, maybe just one or two more examples here. Maybe just one. So the derivative with respect to x of 3x squared over sine x. Once again, quotient rule. So the denominator, sine x, times the derivative of numerator, 6x to the first, minus the numerator, 3x squared, times the derivative of the denominator, cosine x, all over sine x quantity squared. And you can simplify that on your own time. Now, something to note before you get all excited about using the quotient rule. Sometimes you don't need to use the quotient rule. Just rewrite the function instead. And you're like, what? What do you mean? Okay, well, let's look at an example. Okay, say you've got the function y equals x squared plus 3x over 6. You're like, oh, take the derivative. I'm going to have to use quotient rule. I hate that thing. Well, maybe not. Maybe you could just rewrite this as 1/6 times x squared plus 1/6 times 3x. And then just apply your product rule combined with the constant multiple rule to take the derivative. So much nicer, so much faster. You're done. I'm not going to bother writing the derivative there. You can do that. Another example, 5x to the fourth over 8. Well, same kind of thing. You could just rewrite that as 5/8 times x to the fourth. Take the derivative of that would be 5/8 times 4 times x cubed. And why not? Let's go one more example. Y equals 9 over 5x squared. You're thinking, quotient rule, quotient rule, quotient rule. No, 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 no. Just rewrite that. That's just 9/5 times x to the negative 2. Bring that up, and you've got a constant times power of x. Use the power rule. Have a blast. Alright, the last item. You thought we were finished, but we're not. Well, all those other trig derivatives, such as tangent, cotangent, secant, cosecant, can be found using the quotient rule. And let me show you what I mean. Derivative of tangent x. Well, as we all know, tangent can be written as sine x over cosine. So, let's apply quotient rule. The denominator times derivative of the numerator, derivative of sine is cosine, minus the numerator, sine x, times the derivative of the denominator. The derivative of cosine is negative sine, which is why you can see I put in the negative and inside the parentheses. All over cosine of x squared. Great. So this turns out to be cosine squared x plus sine squared x. And then, for whatever reason, I don't know why, I could have just done Pythagorean identity right there. Cosine squared plus sine squared is 1. But I guess I decided to make life difficult for me, and I substituted 1 minus cosine squared, which is the same thing. It's a Pythagorean identity, but whatever. Cancels out the cosine squared. You get 1 over cosine squared x, which, as we all know, is secant squared, because 1 over cosine times 1 over cosine is secant squared. So that's the derivative of tangent. You can use the similar process to find the other trig ratios. For instance, derivative of cotangent is negative cosecant squared x. The derivative of secant x is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. Just a little reminder, remember the cos always have the negative in front of it. Alright, so there you've got it. Your homework assignment is... nope, there's more. Excuse me. We can't get to homework yet because we've got to talk about multiple derivatives. Since the derivative is a function, you can find its derivative as well. For instance, f of x is x to the fourth. Alright, first derivative, 4x cubed, no problem. But what's the derivative of that? Well, that's the second derivative. And you just take the derivative of the first. So bring the 3 out. 3 times 4 is 12. And then you've got x squared. But wait, there's more. Yeah, that's called second derivative. F triple prime of x. That's the third derivative. That's going to be 24x to the first. And so on and so forth ad infinitum. Alright, just to show you an alternative form of writing it here. So if y is sine x, then the derivative, dy over dx, would be cosine x. D squared y over dx squared would be negative sine x, because remember the derivative of cosine is negative sine. The third derivative, d cubed y over dx squared, so sometimes you'll see it in terms of these dy's over dx's with the cubes and the squares and blah, blah, blah. Negative cosine x. And then you got to take the fourth derivative to get back where we started from, and everything repeats, and then you can just continue on to find however many derivatives you want to go, cycling through the sines and cosines, etc. There we have it. Now we're finished. We've talked about the product rule, the quotient rule, the trig derivatives, and multiple